The next type of control structure is called binary. Now, the binary control structure is designed to implement instructions that can have a set condition they equal. Now, most often they are a Boolean condition, which is a yes or no. However, they can also be based on relational, which means some sort of mathematical calculation. The symbols that you'd use there are less than equals, greater than equals, and greater than. And then also we can have logical, so we can have it based on an and or not. So how does this look in pseudocode and flowchart? Well, in pseudocode, it's if whatever condition is true, then do this, else do that. In flowcharts, we use a decision diamond where we test a condition, making sure you label the flow lines, whichever direction you go in. So remember, it doesn't have to be in any particular direction as long as you've got a yes or no. And you can see right away the limitations of flowcharts are the size of them when you get to more advanced control structures. So let's do an example together. So write an algorithm that allows you to enter a mark for a test and then the total marks for the test. So the first thing we want to do is we want to input the mark because it's in there. So we use capitals, reserve word, input marks, and then input total mark. So basically what they're saying is if you've got a mark of 60 and what's out of 100, what's the percentage? So we have the percentage being marks divided by total marks times by 100 to get a percentage. Now, you can see here in the blanks that we have a true condition is print you pass the test, otherwise you fail the test. So our condition is going to be based on the percentage. Now remember, it can be one of three conditions. It can be Boolean, relational, logical. Here, we're going to use a relational. Now we can either use a greater than or greater than equals to. So be really careful. So we're talking up here is there's a difference between a greater than and a greater than equals. So if I wanted to say greater than 49, then that means it's 50% or greater. However, if I want it to be greater than or equal to 50, then that does the same job. It depends on which way you want to do it. So if it's greater than 50, equal to 50, print you passed. Otherwise, you can print some other message like you failed, which is not very nice, but they did fail. And at the end, you can then print the percentage if you want to. So it's really important with if statements that you indent them to show the hierarchy, because you can see right away that we have a sequence here. Remember, every program has a sequence. And we can see here that the show hierarchy, that the indentation shows that there's a true and false condition inside our if statement. Now we'll do one more together. Write an algorithm that allows you to enter two numbers and determine which is the highest number. So remember, first up we input number 1, and then we input number 2. Now, we could have this on the same line if we wanted to, as I said, but for the purpose of this demonstration, I've kept on 2 separate lines. So we have another relational condition here. If number 1 is greater than number 2, then we need to print something along the lines of number 1 is highest. Print. Now remember, anything outside the single double quotes is the variable, which is what we entered here. So we entered number 100, and 100 will display. Otherwise, we print number 2 is the highest number. So it's really important that if statements have a condition inside them and you indent them. Now, if statements, or binaries we call them, are a very common design tool for helping us to test a condition. And you'll see that they're used quite often with inside programs. My advice to you is to download the worksheet attached to this video and to complete it, and then I can have a look at it for you.